So we're going to turn word problems into systems that we can solve. That's the goal. Now, our systems could have two different types of structures, okay? We might have equations that look like this. Y equals mx plus b, right? Where we have a starting point, a b, and one rate. You guys are familiar. Alternatively, we could have equations that look like this. A times x plus b times y equals c, a constant or like a total. Do you remember writing equations like those in Unit 1?
Yeah.
Okay. So we're looking for, do we have a starting point and one rate? Or do we have a total and two rates? Does that make sense? That's what we're looking for. All right. So we have a candy store that has gummy worms selling for $4 a pound and gobstoppers that sell for $2 a pound. Maggie wants a 20-pound mix of gummy worms and gobstoppers, and she's going to sell it for $64. How many pounds of each does she need? In the question, we find our variables, okay? Because the question has to tell us what we're finding. So it is literally telling us the unknowns, and we have to let the variables represent the unknowns. Does that make sense to everybody? That the question tells us what x and y have to be? Okay. So I'm going to look at the question, put it in a box. It says how many pounds of each? What does that mean? How many pounds of what and what?
Gobstoppers and gummy worms.
Yeah, gobstoppers and gummy worms, specifically pounds, because we don't want individual ones. So that's how we are going to set up our variables. So I can't make them both G. Unfortunately, they're both, yeah, I'm going to make the worms the W. So we're going to say let worms be W. We're going to have pounds of gummy worms, not individual ones. And then we can let, let's say S for gobstoppers. Pounds of gobstoppers. Okay, there's really nothing wrong with using X and Y in this situation. But I find when I do that, I have the tendency to flip-flop them at the end when I'm writing the sentence and say the wrong amount of each. Does that make sense? Like I get them confused. So if I pick letters that make sense in the problem, I'm less likely to get them confused at the end. All right, so we found our variables by looking at the question. Now we're going to write the problem as a system of linear equations. So, do you guys see that we've got a whole lot of stuff in here that has to do with money?
Yep.
Okay, so if we're adding up money, shouldn't we have like a total money somewhere? Yeah. So is this something where we have one rate and a starting point or two rates and a total? Good. Okay, so my total is the $64. And then it's $4 for every pound of gummy worms. So that 4 is the coefficient for W. Do you see this? This is an AX plus BY equals C type kind of equation.
Mm-hmm.
Okay. And then it's going to be $2 for every pound of gobstopper. All right, what's my other total? Yes. Okay. Now, if I'm reading this problem over and over again, I can see that I've run out of numbers. I've used all my numbers. Okay, but that's not the only information I have. I also have what I wrote over here. So remember that this is my total pounds. But I also said that W was pounds and S was pounds. So even though I'm out of numbers, what do I know has to add up to 20? S and W. So when you run out of numbers in the problem, don't forget to check your let statements where you defined your variables, right? Because that's good information too. So I'm going to use the W and the S from my let statements and put them in my second equation. So it's pounds of worms plus pounds of gobstoppers adds up to 20 total pounds. Put it upside down. Try putting it upside down. The Velcro works better upside down. I don't know why. Okay. Or not. Okay, now we have our system. We have our variables. We're going to solve it both ways because I want you to have a feel after today of which method you prefer for word problems. Okay? And it might depend on the word problem, but I want you to at least try it both ways. All right, first we're going to try substitution. Remember that for substitution, we need to get a variable isolated. Okay, so we're looking for variables that have a coefficient of 1. That will be the easiest. What do you think? Can I isolate that W, that S, or that W and that S? Yeah, the ones in the second equation are going to be easier. Okay, we can either do this W or that S. So we just have to pick one. The S. All right, I like it. So S, to get S alone, I have to subtract the W from both sides. So that'll be 20 minus W. Okay, so I've rewritten equation 2. That was equation 2. Now I'm going to use equation 1 and substitute into it. So here's equation 1. It says 4W plus 2 times whatever S is, leave room for my substitution, equals 64. But I have an expression that is equivalent to S. S is 20 minus W, so I'm just going to pop that in there and replace my S. Now I have an equation that I could have solved in my first week of algebra with one variable. How do we get rid of grouping symbols, whether they be parentheses or brackets?
Distribute.
Distribute. There we go. So 4W plus 2 times 20 is 40. 2 times negative W is negative 2W equals 64. Now there are two things happening here. I've got to get rid of that 40 and subtract it away. And I also have like terms, my W's that I need to combine. Yep. Okay. So I'm going to combine my W's. I'm also going to subtract away this 40. Okay, that gives me 2W equals 14. Is it 14? No, 24. It's all right. Happens to me all the time. You guys know that. Okay, divide both sides by 2. And W is 12. Now, how many total pounds do we need in the mix? Okay, so if 12 of those 20 are gummy worms, how many pounds are left to be gobstoppers? Good. So our S has to be 8. We will write a sentence after we are done with the elimination one. Any questions about substitution?
Oh,
Easy peasy, lemon squeezy?
yeah.
Okay. All right, here we go. For elimination, remember the strategy is that we are allowed to add our equations together. Now, that's only helpful if I can get something to cancel and eliminate. Okay? So right now, nothing is going to cancel. So the question is, do I want to cancel the W's or do I want to cancel the S's? W's? Okay. So if I want to cancel W's, what would get rid of a positive 4W? A negative 4W. So I'm going to multiply my entire equation 2 by negative 4. Okay? All right, I'm going to rewrite my system. So it's 4W plus 2S equals 64. That's my equation 1. My equation 2 is going through a little change. It's going to get multiplied by negative 4. It's now negative 4W minus 4S equals negative 80. Okay, I could have added before, but it wasn't helpful, but now it is helpful. So I'm allowed to add my equations together. When I do that, my W's cancel, and I get negative 2S equals no, you're close. Negative 16. Okay. Divide both sides by negative 2. And we get S is 8, which is what we got last time. So far, so good. Okay, if there are 20 total pounds, 8 pounds are gobstoppers. How much does that leave for the worms? Yeah. Okay, so now we can write a sentence. So the mix needs, needs a D, needs 12 pounds of gummy worms and 8 pounds of gobstoppers. Yep. He has the pass back.
Yeah,
Okay. All right, here we go. Here's another one. Oh, I need to say one thing about elimination before we move on. For elimination to work for us properly, do you see that our variables are in the same order? We have W's stacked over W's, S's stacked over S's, our equal signs line up, and our constants line up. Does everybody see that? For elimination to work properly, that's how you have to set up your problem. So if your variables have flip-flop spots, you got to rewrite it where they're in the right spots. Does that make sense? Yeah, okay. All right, here we go. Whoa, that's not where I thought I was. Hank's Hardware sells mulch for $3 a pound and potting soil for $2.50 a pound. Hank wants a 60-pound mix of mulch and potting soil that he's going to sell for $170. How many pounds of each does he need? Now, do you see that the A, B, and C telling you what to do are gone?
Yes.
Okay. Does that mean we don't have to define variables anymore? We're off the hook?
No.
You're correct. I still have to define variables. I still have to write a linear system, and I still have to solve and write a sentence. Okay, I still have to do all of that, but the training wheels are gone. Okay. So I want you to think about the question. How many pounds of each does he need? And I want you to write the let statements. Define your variables. Okay, what did we get for our variables? M and P. So we're going to let M be individual little mulchlets. Pounds of mulch. Good. Okay, and then P is okay.
I should have.
Okay. Now I want you to think about your system, your linear system. See if you can identify your totals and write your equations. Go. Okay. What did you guys get?
3M plus 2.5S equals 170.
3m plus 2.5s. Oops. You're fine if you used s. In fact, that's what we used earlier today, but someone told me to do p, so I'm going to do p. Equals, if you used s, that's your p. That's fine. You don't have to change it. 170, right? Is that what you said?
Yeah.
Okay, and then what about the second equation? Good. Is everybody using S?
Yeah.
Okay. Okay, who's using P?
I have negative.
All right,
Yeah.
all right, we're gonna leave it. M plus P equals 60.
Why are you arguing over that?
All right. What do you guys think? Substitution or elimination?
Substitution.
Elimination.
Okay, on the video yesterday, didn't we do substitution?
Yes.
Okay, so I'm gonna do this one with elimination, so it's even. Okay. If you did substitution, it's fine. If you did that already, just make sure you check what your answer was. All right, so do you want to cancel the M's or the P's? The P's? Okay. So I have a positive 2.5p. How am I going to cancel a positive 2.5p? I need a negative 2.5p, right?
Mm-hmm.
Okay, so I'm going to multiply my entire equation 2 by negative 2.5. So here's my new system. 3m plus 2.5p is 170. That's my equation 1. I didn't change him. My new equation 2 is negative 2.5m minus 2.5p is it negative 150? Negative 150. Okay. Now, I could have added before, but it wouldn't have helped me because nothing would have canceled. What's up? You got to wait for the pass, but yeah. Okay, now I'm going to add my equations together.
You might as well just let it go. Because you know it's going to be a while before the person hasn't passed this.
Okay, so 3m minus 2.5m, that gives me 0.5m. My p's, gone, they cancel. 170 minus 150, 20. Okay, now this is about to get weird in here. We're going to wrap our brains around this for like a simpler problem, okay? Because we're about to divide by 0.5, and it's going to get weird. Let's say, for example, that we had 4 candy bars. Okay, and if I divide them in half, how many do I now have? 8. So if I divided 4 by 2, I would get 2. But if I divide 4 by 0.5, I get 8. Is everybody okay that dividing by 1/2 is the same as multiplying by 2?
Mm-hmm.
Okay, so m is going to be bigger than 20. I just didn't want anyone to freak out and think their calculator was broken. Okay, so we're dividing by 0.5. And we get m is, I'm getting 40. So if M is 40, what is our pounds of soil, either P or S, depending on what you picked?
40.
No, it has to add up to 60.
40.
20. So I picked P, so P is 20. All right, now we need a sentence. The mix needs
40 pounds.
40 pounds of mulch and 20 pounds of soil or potting soil. Okay, if you get tired of writing pounds, does anyone know what the abbreviation for yes, LBS, I think it comes from Latin. So pounds is LBS. So if you get sick of writing pounds, LBS. What about ounces? Do you know what the abbreviation for OZ? Okay, like the Wizard of Oz. All right, let's look at this one. Okay, depending on where the cab company is, they charge money in a couple different ways. Okay.
Sorry.
If you're in a town that's very driving intensive, like if you're getting a cab in St. Louis and you're driving a lot, they're going to charge you by the mile because you're spending a lot of money on gas. Does that make sense?
Yeah.
Okay, especially if you've got like open highway. Okay. If you go to New York where you don't really go very far, it would be ridiculous to charge you by the mile if you're only going a few blocks. However, if you're stuck in traffic, it's going to be a lot of time that you're stuck in the cab. So they're not going to charge you by the mile, they're going to charge you by the minute. Does that make sense? Okay. So we have two cab companies in a big city where nobody's going anywhere because of traffic that they're charging by the minute. The drop charge is how much it costs to get your butt in the back seat. So before you even go anywhere, that's just getting your butt in the seat.
What about staying on it?
Okay. Then they're going to kick you out of the cab. Okay. So that's like the starting fee. Good? Okay. So look at these two. Look at these two advertisements. And it says if C is the cost in dollars and M is the number of minutes, which system of equations could be used to determine the number of minutes for which the cab companies charge the same amount? So I want you to look at those two systems and pick the right one. Now be careful. I'm tricky, so I might rearrange stuff a little bit. Think about what gets the coefficient and what would be a constant. Okay, that was a very confident 2. Do we have
I'm pretty confident about
very confident about number 2, as you should be. That is the correct one. Okay, remember that if it's 50 cents per minute and 60 cents per minute, that's what gets the variables, right?
Yes.
Okay. All right, now we're not going to solve this algebraically because it doesn't say that we have to. What powerful solution tool have we not used today?
Calculator.
Yeah, we're going to put these in a calculator. Before we do that, our calculator only uses x and y. So looking at these two equations, is the C going to be our x or y? The y. This is like our y equals. And the m is our independent variable. That's the x. So before you put these in, I want you to make a little table of your own with the x and the y. Remember that the x was the m and the y is the c, the cost in money. Now, what are we looking for on this table? How will we know when we have the right answer? We want the cost to be the what? Yeah, we're looking for the cost or the y's to be the same. Now go. Okay, so this is what I put in my calculator. And if I go to my graph, it looks like they might be intersecting around 9 or 10 or 11, but I can't really tell.
It's
It's
10.
10.
How did you guys figure that out?
You go to the table.
Go to the table. Ding, ding, ding,
I
ding.
mean, it's on paper too.
So when I go, okay, well, yes, way to use the answer choices. Yes, good job. So when my x is 10, both of my y values equal 8. So I'm going to copy that into my table. All right, now look at the answer choices. Are there any that we can eliminate?
The bottom two,
Why the bottom two?
because they have the wrong.
That's about mine.
I would say.
They're not going by mine.
You
Okay,
can cross off 1 and 3 because they're
1
both
and
talking about
3
miles.
because we don't want miles. We want minutes. I agree. Bye-bye.
They have a wrong coefficient.
Okay, so we've narrowed it down to 2 and 4.
Wrong table. Shoot. It's 2.
It's 2. No. Yeah. No.
Okay, I want everybody to make this table.
It's 4.
It's 5. 4.
Okay, it is 4. Because look, the 10 is the x, it's the minutes.
It's 4.
And 8 is the y, which is the cost in money. Okay, the 8 is the cost in money. So it has to be 4. Everybody understand why?
Yeah.
Okay, so this isn't something that I did just for my health. When you're changing over to your calculator and you're making a little switcheroo of your variables, it's very helpful to have a little conversion table like this so that you don't get your x's and y's confused. It took me, 2 seconds to do that? Right? So this isn't something that I want you to just copy down when I do it. I want you to do it for yourselves. Does that make sense?
Yeah.
All right, last question.
That's
Connie.
12 minutes, bro.
Okay, you're saying Connie's cab if we only need a short ride. Why?
The cost of
Yeah.
It costs you $5.
If we're looking at who's cheaper for a short ride, Connie's starts out low but increases faster. So until we get to 10 minutes, she's going to be cheaper. After 10 minutes, Tony's going to be cheaper. Got it?
Yep.
All right, write that in your own words.
That's crazy.
Where's my radio?
Yeah, the other outcomes will charge you
Yeah.
extra cents.
Okay, homework time. You guys did good.